Hello. In this video, I am going to explain how to use 2D NumPy arrays. I am introducing this topic in the context of representing the state of a 2D Ising model. 2D arrays can obviously be used for much more than this, however. You can use this type of Python object to hold any matrix you so choose. So without further ado, let's get into it. The diagram on this slide shows what a microstate of the 2D Ising model looks like. We have a 4x4 lattice of spins and each of these spins can point up or down as shown here. To generate a representation of this object that we can store on a computer, we will use a 2D NumPy array. There will be one element in this array for each of the spins here. These elements will be allowed to equal 1 or minus 1, they will be set equal to 1 if the corresponding spin is in the spin up state, and will be minus 1 if the corresponding spin is in the down state. We can create a NumPy array that could be used to store this microstate by using the command shown on this slide. This command sets each of the elements of the 4x4 array equal to 0, however, as shown in the diagram. We must therefore work through the elements of the array and set them equal to 1 or minus 1 before we do anything that involves the microstate. We can set the element 2,3 of the matrix equal to 1 by using this command. The first number inside the square brackets here is the index of the row. This command is thus telling us to go down 2 rows as shown here. The second number is the column number. This command is thus telling us to go to the third column as shown here. The element we are setting is thus this one. We can use commands like these to set all the elements in the array. Once we have done this, we may then want to calculate the sum of all the spins in the system, as the sum of all the spins is equal to the magnetization. If we want to compute this sum, we would write code like this. The double loop here ensures that we iterate over all of the elements in the array. What we are doing when we do these iterations is adding all of these elements to one single variable total in order to get the magnetization. That should be enough of an introduction to 2D NumPy arrays in Python for you to get started. Now see if you can give the exercises a go. I will reconvene with you to discuss how we can calculate the 2D Ising model Hamiltonian once you are done with those exercises. For now though, thank you for your attention and good luck.